Day 7, the treachery of whales. Oh, those devious whales. A giant whale, that's a whale. Sperm whale, specifically. Has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Suddenly, a swarm of crabs, each in its own tiny submarine, it's too deep for them otherwise, zooms in to rescue you. Thing is, whales don't eat. They don't really eat big things, do they? Their throat is like the size of a. They could only eat something as big as a melon, probably at most. They mostly eat plankton. Well, I don't know about the sperm whale specifically, but I don't think they eat anything big. Just like tiny little fish. So they couldn't even swallow you. They could hold you in their mouth, and that has happened in real life. There have been cases where divers or swimmers have been picked up into the whale's mouth and injured, but you can't be swallowed. Anyway, they seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming. Oh, this is really becoming like Subnautica now. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. There's one major catch. Crab submarines can only move horizontally. You quickly make a list of the horizontal position of each crab. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. Oh, yeah, this is a classic problem. For example, consider the following horizontal positions. This means there's a crab with horizontal position 16. All right. So I believe the answer is you pick the median value and bring them all to that. Not the average, but the median. If you go with the average, you can actually get a wrong answer, I think. But yeah, if you pick the median, then that minimizes it because all the ones to the left increase, all the ones to the right decrease. And that minimizes the amount of change you need to make. Okay. Those are the crabs, okay. Alright, so we've got the crab values. And basically we want to sort them. And then we want to pick the median. Be crabs. I wonder if there's a built-in routine for finding the median. But I mean, we could just do crabs length of 2. And then the answer will be basically how much it costs to bring them all to the median, I think. So for C in for crab in crabs. So fuel is going to be the absolute value of crab from the median, how long it takes to get there. And then we print the total amount of fuel. I think that should be the answer. Correct. This is a good problem because I think a lot of people will use the average. The first time I saw a problem like this, I think, was in the Google Code Jam. And it tripped up a lot of people. Because they just immediately, instinctively went for the average and just tried to get every crab to go to the average location. But that's wrong. And you could prove it's wrong by just having an obscure example where there's like a million high values and one small one or something. So let's say you had like a 1,000 crabs at 100 and one crab at 1. And you took the average. The average is going to be somewhere in between, very close to 100. So then all those 100 crabs are going to move to the average. That's a lot of fuel spent. But the median would be 100 because practically all of the crabs are already at 100. So then none of those crabs will move to the median. Only the one crab at 1 will have to move to the median. That's how you minimize the amount of fuel. But you can prove it mathematically properly. But yeah, median. It's often the case you need to use the median and not the average in problems. Part 2. Crabs don't seem interested in your proposed solution. Perhaps you misunderstand crab engineering. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of one step in horizontal position costs one more unit of fuel than the last. Okay. So it's no longer going to be the median. So now you're really trying to minimize. So now you're no longer trying to split it halfway, but you're trying to minimize the max. Like you're trying to avoid any crabs with huge amounts of movement to some extent. I mean, at this point, you just have to compute the cost for every possible midpoint, I guess. This costs a total of... Determine the horizontal position that the crabs can align to using the least fuel possible so they can make you an escape route. How much fuel must they spend to align to that position? At this point, I don't think it's going to be anything nice and clean, like just using the median. If it's linear, it's the median. This is not linear, but it's not even exponential or geometric. It's using a 1, then 2, then 3. That's no. So I think we just have to. How many values have we got here? Yeah, it's not a big range. It's like a 1,100, 1,200 or so. 0 to about 1,200 at most. So we could just try every possible midpoint and just compute what the cost is of moving all the crabs there. So And these, what are these numbers called? The triangle numbers, where you add 1 plus 2 plus 3 plus 4. Or triangle numbers. I'm trying to think if this is just going to be... So it's going to be 1,000 different values we try. And for each of those... So how many crabs have we got? Each of those, we just compute it for every crab. There's 1,000 crabs. Okay, so it's 1,000,000 operations. That's fine, we could do that. So... for midpoint in range, so the lowest one we'll have is min crabs, and the highest one we'll have is max crabs. So for each of those midpoints, we want to compute the amount of fuel spent So the distance will be the absolute value of crab minus midpoint. So if it's a distance of x, then the amount of fuel spent is going to be one plus 2 plus 3 plus 4 up to and including x. So the formula is the arithmetic sum formula, which I just gonna Google. Call this D. The arithmetic sum formula is going to be we're starting at 1, so it's the simplified version. It's just going to be like, so it's going to be 2 plus 2 plus n minus 1 times the difference, so it's just 1. Okay, so that becomes d plus 1. Oh yeah, of course, it's just d plus 1 times d over 2. This is the standard triangle sum formula. Why doesn't it like that? Statement seems to have no... Oh, yeah, okay. So that should be the sum fuel plus equal. I think that's it. If best fuel is none, so we haven't tried anything yet, or we found a new best fuel, and best fuel equals fuel. So after this, we've found the best amount of fuel to use. And it's that. Correct. Just thinking if there's any simple formula for this. So we're basically computing, minimizing the sum of that. I don't think there is, because that's quadratic, and you're minimizing the. Yeah, it doesn't have the nice neatness that you have with the median. This is not linear anymore. So I don't think there's some like simple average like the mean or the harmonic average. I can't even remember what the harmonic average means, or just something nice and neat like that. I think you just have to compute this sum. Let me just print what the midpoint was. Out of interest. So that was the best. It was at 470. 70, interesting. And what was the median? Median was 337. It's a bit higher than the median. What was the average? $470. So it's the average. Oh, hang on. So the answer is actually the average. Is that always the case? Oh, I can't think right now. I've probably seen similar problems to this before. So you're minimizing a sum of quadratics. There's some reasoning, but I think, yeah, the answer apparently is just take the average. So median if it's linear, average if it's quadratic. I think if I were to bother to write this out with pen and paper, I think if you were to start putting these D is crab minus midpoint. You put that into this formula here, and you're summing up all the fuels over all the crabs. I think, yeah, I think I can sort of see why it reduces to minimize. Oops, reduces to minimizing this. Because this becomes... You have to write out the sigma notation, and I think it will just fall out somehow. You end up minimizing that, and for the median, you're minimizing the not minimizing anything, you're just taking the middle value. Anyway, I'm not too bothered about the maths behind it. It worked, and we didn't have to. So he could have made it harder, and made the value so big that you couldn't do that, and you had to work out that it has to be the average. That would have been a good problem as well. Same for the median. Except, like, you couldn't make the values. You couldn't make. The median is linear, so it's not like you could make the inputs so big that you can't. Computing the median is equivalent computationally to computing the just the sum of all the fuel values and finding the minimum. Actually, not quite. Median is actually easier. Anyway, so that's day 7 done. Take a look at the old leaderboard. Alright, we're in the top 10. Captain Coda's leaderboard? I don't think Captain Coda is ever intending to come to... Oh! For some reason, Captain Coda has done part 1 of day 25. Why? Of all the problems to do, why would you do 25 specifically? Maybe he meant to do a different year and he accidentally clicked on the wrong year and then just ended up doing this problem before he realized. I don't know. Interesting. Okay. So clearly it gets harder after day 7. And of course, this was back in the days before ChatGPT, so people were solving the problems properly. So these are the times: 1 minute, 1 minute, 4 minutes, 4 minutes, 3 minutes, 2 minutes, 1 minute and a half. I can believe that. They're all recognizable patterns. Once you recognize what the problem is, and you've probably seen it before, then if you've got lots of stuff stored where you solved it before, you just have to call that up. What took the longest? This one. Problem 4. The giant squid one. Yeah, because this you have to format the boards and stuff. So that was bound to take longer. Spend more time parsing. Alright, well, we did 7 problems in 2.5 hours. That's good. We just have... So basically a quarter of the way, just over a quarter of the way. But they get harder, for sure. And this was the year... So 2019 was the year with the heavy int code. Every other problem was an int code problem, which some people liked, some people didn't. I quite liked it, but I also found it quite taxing because it means you had to get all the past int code problems correct to be able to continue. So it's not independent. So like you can't just jump into a later problem. You have to kind of do them in sequence and get them right. Which I can see being frustrating for people who just can't solve a problem and just want to move on to the next one, but you can't really do that. All right. We'll stop there. I doubt that there's anyone online doing Advent of Code. I'm not even going to check. It's not the time of the year, so we won't raid. All right, well, I'll continue with this over the coming month. See you next time.